man's pipe dream. Surging with life-giving water and tons of waste. Feeding the fixtures that spoil us and flushing us with pride. Its potential is explosive, and its history overflows with innovation. Now, plumbing on Modern Marvels. If there's one fact of life we all hold in common, it's our dependence on water. Regardless of race, creed, or social status, we all rely on it for our very survival. We've been depending on the craft and science of plumbing for thousands of years, as it enables us to bring fresh water where we need it and take dangerous wastewater away.
Even though we kind of become complacent in the industry in so much as what we do every day, we kind of lose sight of the fact that the plumber is a very important part in the health industry. We don't have the outbreaks of diseases. We don't have any of the things that we had as little as 100 years ago or less.
Throughout history, the ability to control water has been one of the defining elements of a sophisticated culture.
Plumbing is civilization. Just about every civilization that we look back on in antiquity that we study and admire for their contributions to art and literature and science, technology, civil order, also were highly developed plumbers.
Early concepts of plumbing, mere ditches in the ground, have developed into complex networks of pipes capable of supplying water to cities of millions. Ever wondered how much plumbing pipe you've got in your home? The average American house has over 700 feet hidden between the walls and under the floorboards, allowing everyone in the house to consume more than 50 gallons of water per day.
Whenever somebody thinks of a plumber, they think of the guy that came and fixed their toilet and charged too much. But it's quite a mechanical trade with a great deal of skill and a great deal of knowledge involved in it.
To reach the fixtures that place it at our fingertips, water is often transported hundreds of miles from its source, above and below ground. Once it reaches the city, thousands of miles of underground water mains carry it into buildings, where water flows hot and cold at our beck and call. One universal force of nature drives the water from point A to point B and maintains pressure in the pipes. Gravity. Water is pumped to the top of giant towers, which are connected to the mains beneath the streets. As long as the tower is higher than the water's final destination, gravity will maintain pressure and force water through the pipes. In buildings that are taller than the water tower, water is pumped to a series of pressure tanks inside, each using gravity to feed the floors below it. After water is used, gravity once again carries it away. Sewer pipes are built at an angle so that wastewater can flow downhill. After sewage has been treated, it flows by gravity into the nearest waterway, where it's reclaimed by the earth. Mastering the basics of plumbing across the centuries has allowed us to take the art and technology of the craft to new levels. We've got fixtures to pamper us, and fixtures that conserve water. Some elaborate systems pump water to the tops of 100-story skyscrapers, while others convert salty seawater into drinking water. State-of-the-art plumbing is even snaking its way into America's growing number of new sports arenas. San Diego's Petco Park boasts an array of plumbing advances that meet all the needs of 42,000 baseball fans.
The project contained over 200,000 feet of pipe, which is approximately 38 plus miles. There are approximately 30 point-of-use electric water heaters, approximately 520 toilets, 225 urinals, and approximately 450 lavatories.
Engineers designed the park's vast plumbing network not with blueprints, but with computer-assisted drawings, or CADs.
The CAD drawing system that we use expedites the drawing process. Rather than using the traditional, what we call stick drawing, he can pull that up on a CAD drawing and he can see the background of all systems. He looks at that for coordination. It allows him to see where the walls are, where the structure is, confirming that we don't have a duct line and a water line or a sewer line in the same location.
All the water that the stadium uses for everything from its fountain and concession stands to field irrigation and firefighting first passes through here, the heart of the plumbing system.
We are in the domestic water booster pump room. This is where the incoming water comes from the city. The water is boosted in pressure with a triplex pump system. This is to compensate for any variables in city water pressure to keep a constant water flow to the building itself.
Huge pumps also regulate water flow once it's in the stadium complex. This ensures that even during the seventh inning stretch, when 40,000 fans just might use the bathrooms all at once, water pressure remains uninterrupted.
When there's a demand for the water upstairs from the toilets being flushed and the sinks being used, this system will sense that and turn on the first pump, but not at the full operating level. This box is a computerized system inside. It actually has a little CPU inside that has sensors throughout this system to make it operate.
Before the stadium opened, plumbing contractors tested this high-tech system using a method any fraternity prankster would salute. Hundreds of volunteers stationed themselves throughout the stadium's restrooms for a super flush. At a signal, they would simultaneously flush almost all of the 520 toilets. To simulate the moment of maximum water usage during a game.
The reason for the super flush is to make sure that the plumbing system works per design. And what we're talking about is to make sure that when we have a seventh inning stretch, when most people use the restrooms and go use the concession stands, the water usage is usually at its peak volume. And we're assuring that the pipe sizes and the sewage system will operate properly. And it actually went very well. And we had no backups, no overflows, and it was over quite quickly.
The only thing more reliant on Petco's plumbing system than the fans is its lush manicured turf. 85 powerful sprinklers, divided into 19 watering zones, spray the 110,000 square foot playing field.
On the average, this head puts out approximately 17 gallons per minute, okay? So if we're running the system on an average night, one head would put out approximately 340 gallons, okay? If you do the multiplication, you get the whole field. On your average night during the season, if we were to water, it'd be about 27,000 gallons of water on the whole field.
Each sprinkler head is equipped with an electronic sensor and can be adjusted via the internet or by remote control.
But you can adjust the spray, you can adjust the nozzles, how far the spray is going, the degree, if you want to make it 180 degree or 230 degree. You know, baseball field has a lot of angles. You can be out there on the field with the remote and pop those heads up and make adjustments on the spot instead of running back and forth to the clock.
Whether the water at Petco Park is flowing to the field or to the fans, all of it travels through pipes tailor-made to withstand California's ever-present earthquakes.
If we look up above here, the overhead piping at this point at a seismic joint requires some flexibility. And as you can see, you see the braided flex, and you'll see the additional fittings that are there. And in an earthquake, this allows that pipe to move and not twist, break.
Most of us take high-tech plumbing systems like the one at Petco Park for granted, just as we give little thought to plumbing in our own homes. But surprisingly, most of America didn't have what we'd consider basic indoor plumbing until as recently as the turn of the 20th century. Still, its principles can be traced back thousands of years.
All the early civilizations knew that they would take the water upstream and they discharged their waste downstream. If you look at the original plumbing, that was the premise for it.
Archaeologists have discovered plumbing's earliest artifacts in Iraq, once the heart of ancient Mesopotamia. They've unearthed traces of a crude waste disposal system, primitive drains and cesspits dating back as far as 6000 BC. But excavators found no evidence of any method of transporting water to where the residents lived. 1,500 miles away, in the Indus Valley, an ancient culture called the Harappans developed an impressive waste disposal system around 2500 BC. It began with something resembling a toilet.
These structures were built of stacked brick with a seat and actually a wooden cover that went over the seat. And these then drained into, at intersections of streets, into cesspools, which had stairs so that the workers could walk down in and clean up.
By the 6th century BC, builders of the Mesopotamian city of Babylon still hadn't solved the other half of plumbing's equation: a continuous freshwater delivery system. But their method of irrigating Babylon's famous hanging gardens, 350 feet atop the palace walls, was a step in the right direction. At the base of the palace wall, the Babylonians built a reservoir. The water was raised by means of a slave-powered chain pump, which had 2 large wheels like a ski lift. Ceramic pots or buckets hanging from the chain were continuously dipped into the reservoir. Once water reached the top of the gardens, it could be released from gates into irrigation troughs. By around 1500 BC, 800 miles from Babylon, the ancient Egyptians took water delivery a step further, diverting it inland from the Nile for irrigation and bathing.
What they had were their artisans that were making their clay jugs figured out a way to, instead of making a jug with the bottom to it, they made it into pipe, and they made short sections. So the Egyptians were considered some of the first to be able to transport water through a conduit, through pipe.
Around 400 BC, the ancient Greeks took plumbing to a whole new level by combining the use of waste removal and water transportation devices. To deliver water, the Greeks built rudimentary aqueducts, stone-covered channels that followed the slope of the ground and let gravity do the work. To prevent enemies from sabotaging their water supply, the Greeks buried most aqueducts underground to a depth of up to 14 feet. Once the water flowed into the city, it was held in storage cisterns. The water was then used for fountains and the ancient world's newest plumbing innovation, the bathtub. To dispose of waste, many Greeks equipped their homes with latrines that drained into a sewer beneath the street. The sewer then carried the waste to surrounding rivers.
The interesting thing is all these areas were still discharging to a watercourse. So they didn't know that much about pollution other than the fact that the human waste was, had an odor to it.